In this lesson, we will look at factoring quadratic trinomials in standard form, and that means whether a is 1 or something other than 1. And we'll also be factoring the sum or difference of cubes. First, factoring trinomials. If you're given ax squared plus bx plus c, first step, always identify and remove any greatest common factor. That was the previous lesson. Then you're left with ax squared plus bx plus c without any common factors. At this point, we have what's called a trinomial. What we want to do is we want to multiply a times c. That's the coefficient of the x squared and the constant. And then once we have that value, we're going to create our star. Okay? It's just an x with a line through the middle. And we're going to put AC here, AX here, B here. All of this is stuff that's very easy. It's just you pull straight off, no thinking. Then we have to list mentally or on paper all the factors of the product A times C. And we want to identify the factors of AC that sum or add to B. These factors will be referred to as B1 and B2. Now, if A is equal to 1, as soon as you have B1 and B2 here and here, then you have your factors. Okay? And the reason you have your factors is because then you take AX over B1, AX over B2. But since A is equal to 1, we don't actually write the A in there. Oops, didn't mean to get rid of my X. So we still have our X here. And that's not negative. So then what we do is just do called bottoms up. Sorry, wrong direction, blue. And here. Okay, so it's just bottoms up. Now, like I said, when A is 1, these are much easier. So let's go through a few. And I have no idea why this is so slow. There we go. If we want to factor p squared plus 8p plus 7, we first identify and remove any greatest common factor. There is none, so we continue. Now we're going to identify A, B, and C in the remaining trinomial. A is 1. Okay. Notice it's understood to be 1 here. B is 8, and then C is 7. Now we're going to multiply A times C, or 1 times 7, and we get 7. And we put 7 here in our star. We're going to create our star. AX is just X and X, and then the B value is 8. Now, I need factors of AC that sum to 8. Well, that's 1 and 7. So I put those here. Now, I have my factors. X over 1, X over 7. And if you just think about bottoms up, and remember both of these are positive, you get X plus 1, boom, and then you get X plus 7. And you're there. Okay? And 1 and 7, that's the hard part. That's what those two numbers, okay, 1 times 7 equals 7, 1 plus 7 equals 8. They have to multiply here, and then they have to add to this value. Let's try several more. It pretty much solidifies it when you start trying them. Okay, I'm going to try a couple of these, and then I'm going to let you try this last one here. So first, we look at this, and I know AX is just P, and I put X here. You know, we can go back and make it P. So that way, it will make a lot more sense. Okay? So, first, we write down the P and the P. It's P squared, but I don't want this squared here. I just want the variable. And the coefficient A is 1, so we don't write down a 1. Then 8 is the value of B. Boom. Easy peasy. Then 1 times 16 is 16. Remember that this is A times C. Now the thinking part comes. What two numbers multiply to 16 and add to 8? Well, we have 1 times 16, 2 times 8, and 4 times 4. 4 times 4 will do it. There's our numbers. Now, I can take these and I can say I've got P over positive 4 and P over positive 4. Neither one of these fractions reduce, so I simply do bottoms up, and I have P plus 4 times P plus 4. Now, if you wanted to check this, I'm only going to do this once, but if you want to check, remember you can multiply these together. So this means you've got to double distribute, double FOIL. P times P is P squared, okay? And then P times 4 is 4P. 4 times P is another 4P, and then 4 times 4 is 16. 4P plus 4P is 8P, P squared plus 8P plus 16. That checks. That's the exact same thing that we started with. So remember, you can always multiply it back together to double check your answer. Right? But now, just so that you know, right here is what your answer is. Okay? To not leave it in the fraction form, you got to write it as a set of factors. Okay? The next one, we have the value of B is 18. I got the V and the V. Those are easy. Then A times C, 1 times 80 is 80. Two numbers that will multiply to 80 and add to 18. Did you get 10 and 8? Fantastic. Well, now this means that we have V over positive 10 and V over positive 8. Neither one of these fractions reduce, so all I have to do is bottoms up. V plus 10, I don't know why I did that curvy one there, and then V plus 8. I think my mind was on the parentheses. Okay? All right, pause the video for a moment and try this one. Let's see how you did. Okay. Did you fill in your star correctly? If you've got your star filled in, the rest of it should be pretty easy. Okay. Remember, I need 1 times 18 is 18. The B value is 9. Two numbers that multiply to 18 and add to 9 are 3 and 6. This gives me x over 3 and x over 6. You don't have to put the plus here, but if it helps you to remember what you're doing, you can. And then you just do your bottoms up, and your factors are x plus 3 and x plus 6. Okay, this is an important skill. So what I want you to do is pause the video and try these three. When you're done, start the video and see how you did. You're back? All right, I'm going to uncover each one of these and walk it through. So this first one over here, okay, r over 6 doesn't reduce. It's r over 6 right here. And so if I do bottoms up, I'm going to get r plus 6. Over here, if I do my bottoms up, I'm going to get my r minus 7. Notice that when a is equal to 1, the fraction will never reduce, which makes it really easy. Over here, again, I do my bottoms up, okay? N minus 9, N plus 8. If it's positive, it's plus. And finally, over here, bottoms up. The two numbers that multiply to 30 and add to 11 are 5 and 6, which give us factors of V plus 5 and v plus 6. So this is actually a lot easier than you may have thought it would be. Okay? It just takes some practice. The biggest thing is you've got to know your multiplication tables. If you know your multiplication tables, the rest of it is just filling in the star. Now, what if there is a GCF? Oh, okay, well first, over here, 4 goes into 4, 56, and 192. And here's my factored trinomial. So now I've got x and x, 14's in the middle. 1 times 48, because remember a is now 1, is just 48. Two numbers that multiply to 48 and add to 14 are 6 and 8. But now, here's what you have to remember. Your final answer, you have to bring the greatest common factor down, and then you do bottoms up with these, and so you have x plus 6 and x plus 8. You have to provide all 3 factors, okay? Let's try this one over here. If you want to, you can pause the video for a moment and do it yourself, and then come back. You ready to try? Well, this one, I'm going to guess 3. 3 goes into itself. Will 3 go into 42? 4 plus 2 is 6. Yep. Will it go into 135? 1 plus 3 is 4, plus 5 is 9. Yes. Remember, if the sum of the digits is divisible by 3, then so is the number. So I'm going to get 3, and that's going to leave me with p squared, plus, it's going very slow here, p squared plus 14p plus 45. All right, p and p. I didn't exactly write p and p here, but we'll make this a p so that it's correct. Okay, there's my p and p. Then a times c is 45, b is 14. Two numbers that will multiply to 45 and add to 14, that's 9 and 5. Do not forget, when you write your final answer, you have to have your greatest common factor, and then you can have your 2 binomial factors, p plus 9 and p plus 5. These are 2 linear binomial factors. Boop, there's 5. Okay? But what happens when a does not equal 1? Well, don't worry. It's the same basic process that we've been working on, okay? Same basic process. Except now I need a times 5. Well, a times 5 is 4 times negative 9 is negative 36. And then the negative 5. Now I still need 2 numbers that will multiply to negative 36 and add to negative 5. And that's negative 9 and 4. Negative 9 times 4 is negative 36. Negative 9 plus 4 is negative 5. Now, this right here, this is all, whoops, this is all the same. The extra step is here. You're going to reduce the fractions and bottoms up. So by reducing the fractions, you're going to take this fraction and this fraction, the 2 sides of your star, and you're going to write 4x over negative 9. It doesn't reduce, so I'm just going to do bottoms up. Over here, I have 4x over 4. This reduces to x over 1. You still need a denominator. Don't get rid of the denominator, because the 4's cancel. 4 will go into 4 once. Now you can bottoms up, and your final answer is going to be 4x minus 9 times x plus 1. Wow, that was pretty easy. The only thing you have to remember is you got to reduce and then bottoms up. The reducing, that's the extra step. let's try this one. 2, 1, negative 15. I don't have a greatest common factor. So I'm going to multiply 2 times negative 15, and I get negative 30. And then the value of b is 1. Two numbers that will multiply to negative 30 and add to positive 1 would be 6 and negative 5. So now I'm going to write down my fractions. X over 6. That's reduced. So bottoms up on that one. Oh, whoops. I did not write this correctly. Actually, that part's correct. Sorry. What did I miss? I'll show you. I forgot this is 2x and 2x. Okay? I need my value of a in here. Now I'm going to write my fractions. 2x over 6 reduces to x over 3. And now I can bottoms up. And 2x over negative 5 does not reduce. So I simply bottoms up it. X plus 3, 2x minus 5. That's all there is to it. Really not that hard. Okay, try these three. Pause the video and try these. Okay, let's see how we did. 3 times negative 12 is negative 36, adds up to 16. That would be negative 2 times 18 is negative 36. It adds to 16. Fantastic. 3x over negative 2, 3x over 18. 3x over negative 2 does not reduce, so bottoms up. This one reduces to x over 6. And then bottoms up, 3x minus 2, x plus 6. You have to have this. If all you do is stop right here, okay, you're going to wind up with 2 out of 4 points. Okay? It's a major mistake. I'm asking you for the factors, not for a fraction. The fraction is just a way to show your work, a way to help you focus. Right? Over here, did you get 2 times negative 5 is negative 10? You got your 9. You got your 2x and your 2x. Factors of negative 10 that add to 9, negative 1 and 10. Now we're going to get 2x over negative 1. Does not reduce, so we bottoms up. 2x over 10 reduces to x over 5. And now we can bottoms up. So we have 2x minus 1 times x plus 5. And there you have it. Finally, over here, 3 times negative 8 is negative 24. We've got the 3x and the 3x because this is so that I can, remember when a is not 1, I got to figure out how to break it up, okay? When it's 3 and 2, I know it's going to be 3x and 1x, but I got to know where the b values go, okay? So now, two numbers that multiply to negative 24 and add to 10. Hopefully you picked out negative 2 and positive 12. So then again, you've got your 3x over negative 2. Just bottoms up. 3x over 12 is going to result in x over 4. And then we bottoms up. And here are your factors. Okay? All right. Last method for factoring. Sum and difference of cubes. Factoring the sum and difference of cubes. Notice that when we did the difference of squares, only the difference of squares work. You couldn't do a sum. With cubes, it's different. Both work. And it's just a pattern. Okay, remember the pattern. The factors for a sum or difference of a perfect cube is just a pattern. That means you're going to need to memorize it. To help with remembering, we have the mnemonic SOAP, which stands for same sign, opposite sign, always positive. That way there's no thinking about, ooh, am I adding or subtracting? So here it is. If I've got a cubed plus b cubed, very first thing I'm going to do is put plus, minus, plus. And I know that because it's the same. This was addition, so this is addition. Opposite, the opposite of addition is subtraction, and then it's always positive. Then, these are the cube roots. So I've got a and b. And then I'm going to square the first one, multiply the two of them together, and then square the second one. So a squared is here. A times b goes here, and b squared goes here. Notice I don't need to think about, and I just take the absolute values of those. Again, over here, same, it's subtraction. Opposite, it adds, always positive. Boom. This pattern, cube roots and then squared, multiplied, squared, that's all. You just have to memorize it. Let's look at some numerical answers, or some numerical problems. Oop, there we go. There's our pattern. Okay, x cubed minus 8. First, you might ask, what are some of the cubes we have? Well, let's look at some real quick here, okay? We have 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is equal to 125. 6 cubed is equal to 216, and really you don't have to go a whole lot farther than that. You should also know, however, that 10 cubed is 1,000. Okay? Now, x cubed, and any degree that is a multiple of 3 is a variable cubed. So x cubed, the x is a perfect cube. 8 is a perfect cube. So the first thing I'm going to do is I'm going to set up my parentheses, and I'm going to do 2 and 3. Same sign, minus. Opposite sign, plus. Always plus, boom. Then the cube root of x cubed is x. The cube root of 8 is 2. I have now done all the hard work. I take this first term and square it, x squared. Then I multiply the 2 times the x. I don't pay attention to whether this is plus or minus, just the number times its variable. And I get 2x. And then the 2 squared is 4. And I'm done. Should we multiply it out and check it? Absolutely. X times x squared is x cubed. X times 2x is 2x squared. X times 4 is 4x. And we have negative 2 times x squared is minus 2x squared. Negative 2 times 2x is minus 4x. Negative 2 times positive 4 is minus 8. I'd like for you to notice that 2x squared minus 2x squared becomes 0. 4x minus 4x becomes 0. And we are left with x cubed minus 8. And it checks. Let's try this one over here. 27x to the 6th plus 64. Again, I'm going to set up my parentheses. 27 is a perfect cube, x to the 6th is a perfect cube, and 64 is a perfect cube. So the same sign, the opposite sign, and then always plus. The cube root of 27 is 3. The cube root of x to the 6th is x squared. 6 divided by 3 is 2. 64's cube root is 4. Then I take and I square just this first term, so I get 9x to the 4th. Then I'm going to multiply these two together. 3 times 4 is 12x squared, and then I'm going to square the 16, or square the 4, and I get 16. And you're done. Okay, now this one, remember that if you have x squared times x squared times x squared, you get x to the 6th. So the cube root is just one of these guys. Okay, let's look at these next two. 8x cubed minus 1. Perfect cube, perfect cube. So I'm going to need my 2 and my 3. My same, my opposite, and my always positive, or always plus. The cube root of 8 is 2. The cube root of x cubed is x. The cube root of 1 is 1. 2x quantity squared is 4x squared. Then 2x times 1 is 2x. And then finally, 1 squared is 1. Okay. Now what about this last one over here? Oh, we have a problem. Okay? We don't have a perfect cube except for the variable. But remember we have a greatest common factor. 2 times x cubed plus 8. Now I have a sum of cubes. I have to keep my greatest common factor, and then I'm going to use SOAP again. So it's going to be plus, the same, the opposite, always positive, and then I've got cube root, squared, multiplied, squared. Just a pattern. And if you do enough of the problems and then you review the pattern before the test, you should be fine. So here are 3 more. Okay? Try these 3 and see how you do. Pause the video and then you can check. Okay. Notice, same, opposite, always positive, same, opposite, always positive on each one of these. The cube root, okay? We're looking at things like the cube root of 8x cubed is 2x. The cube root of 125x cubed is 5x. Square, multiply, square. Square, multiply, square. Okay? That wasn't too bad, was it? So remember, keep it clean. Use SOAP to factor a sum and difference of cubes. When you see 3, remember that one of your factors needs to have 3 terms, 2 terms and then 3 terms. Okay? If you want to double check, you may multiply the factors back together to prove that the factor form is equivalent to the original standard form of the polynomial, which I did with the first problem we tried. And that's it. It's now time for you to practice.